Good day, everyone. I hope you're all doing well today. We are the Group 1, and today we are going to embark on a journey through time to explore the fascinating topic of the historical development of science and technology. From ancient discoveries to modern innovations, we will uncover the incredible advancements that have shaped the world we live in today. So, first, let's begin with our objectives. First, we will classify the key scientific and technological advancement during the prehistoric era. Second, we will describe the contributions of ancient civilization, Egypt, Mesopotamia, Indus Valley, China, to science and technology. Third, we will analyze the scientific and technological development during the Middle Ages and Renaissance. Fourth, we will evaluate the major breakthroughs and impacts of the scientific revolution. Fifth, we will compare the technological achievements of different ancient civilizations. Sixth, we will assess the long-term impacts of early scientific discoveries on modern science. And lastly, we will discuss how historical context influenced the development of science and technology. These objectives are also included on our course guide.
Prehistoric humans began crafting tools from stones, bones, and wood. The development of tools marked a significant advancement in early technology, enabling better hunting, food preparation, and overall survival. Fire control. The mastery of fire was a crucial advancement during the prehistoric era. Fire provided warmth, protection from predators, and cooking capabilities. This technological development revolutionized early human lifestyle. The hunting techniques. Hunters in the Stone Age used bows and arrows as tools. These might be used to draw larger creatures in the forest as well as birds and smaller mammals from a distance. The shape of the arrow changed over time as well as depending on the target, so prehistoric humans refined their hunting techniques, transitioning from scavenging to actively hunting animals. This improvement in hunting method allowed for more consistent food supply and contributed to human evolution. The shelter construction. Early humans started building shelters using natural materials like branches, leaves, and animal hides. Shelter construction not only provided protection from the elements but also laid the foundation for communal living and social organization. The cave art. It still remained unclear why cave paintings and drawings were made despite lots of explanation, and some believe that it served as maps for early humans while others think it's part of a ceremony or rituals. So the creation of cave art reflects the cognitive and creative abilities of prehistoric humans. These artistic expressions not only serve as a form of communication but also showcase early humans' capacity for symbolism and cultural development. So, the language development. Although not tangible, the development of language was crucial scientific advancement during the prehistoric era. The ability to communicate complex ideas and share knowledge enhanced early human societal and technological progress.
Land agriculture. Early humans began cultivating crops and domesticating animals, which led to settled communities. For example, the cultivation of wheat and barley in the Fertile Crescent allowed for more stable food supplies. Tool specification. Early humans developed specific tools for different tasks, such as stone axes for cutting wood and flint knives for hunting. The refinement of these tools, like the hand axe, improved efficiency in daily tasks. And lastly, navigation. Prehistoric humans used natural landmarks and the stars for navigation, particularly for migration and hunting. For example, early seafarers in the Pacific navigated vast ocean distances using the position of the stars and the ocean currents. Contributions of ancient civilizations like Egypt, Mesopotamia, Indus Valley and China to the science and technology. In Egypt, advancement in astronomy, mathematics, and the medicine were made, including the development of the 365-day calendar and the construction of the pyramids using advanced engineering techniques. Mesopotamia is known for pioneering the wheel, the first writing system called the cuneiform, and the development of mathematics through inventions like the sexagesimal system. The Indus Valley Civilization had sophisticated urban planning with the advanced drainage systems and well-organized cities, indicating an understanding of mathematics and engineering principles. Chinese also made significant contributions to understanding celestial phenomena and developing accurate calendars. Additionally, Chinese medical practitioners made important discoveries in anatomy, herbal medicine, and acupuncture. So, this civilization laid important foundations for modern science and technology.
During the Middle Ages, there is a significant progress in first agriculture. New tools and farming methods helped produce more food so more people could live. While in architecture, a new architectural style allowed for taller and more impressive buildings. In medical field, surgery and knowledge about the human body improved. The Renaissance was a time of great change in Europe that began in 14th century and lasted into 17th century. It was called a rebirth because people became very interested in rediscovering and building the knowledge from ancient Greece and Rome. This led to major advances in science, art, literature, and other areas. People started to focus more on human experience and potential, which sparked a lot of new ideas and discoveries. Leonardo da Vinci was a key figure in the Renaissance, who made major discoveries in anatomy, engineering, and astronomy. He is known for combining knowledge from different fields, showing the Renaissance focus on learning broadly. While Johannes Gutenberg's printing press made it possible to quickly and cheaply produce many books. This helped spread new ideas and literature to more people. In terms of technology, during the Renaissance, new tools like the telescope, microscope, and compass were invented. These innovations helped people explore and understand the world better, paving the way for modern science. And better shipbuilding and navigation techniques during the Renaissance made it easier for people to explore new lands.
Thank you, Ms. Pinaverde. Good morning, everyone. I'm Ruby Tabia, and I will continue the discussion about the major breakthroughs and impacts of the scientific revolution. The scientific revolution, which took place from the 16th to the 17th century, was a transformative period in human history that had far-reaching impacts on various aspects of society. The first one is heliocentric theory of Nicholas Copernicus. It proposed that the Earth orbits the Sun, challenging the long heliocentric model. Impact laid the foundation for modern astronomy and altered our understanding of the universe. Means he proposed that the Earth revolves around the Sun, changing our view of the solar system. Second, laws of motion and universal gravitation of Isaac Newton formulated the laws of motion and universal gravitation, unifying celestial and terrestrial mechanics. Impact provided a comprehensive framework for understanding physical forces, critical for advancements in physics and engineering. Means he established the principles that explain how objects move and attract each other, forming the basis of physics. Third, scientific method of Roger Bacon and Rene Descartes emphasized empirical observation and rational deduction as a systematic approach to scientific inquiry. Impact standardized research methods becoming central to modern scientific investigation and experimentation. They introduced a systematic way of investigating the world through observation and reasoning. Fourth, advances in medicines of Andrea Vesalius and William Harvey. Detailed studies of human anatomy and discovery of blood circulation. Impact revolutionized medical knowledge and practices, improving understanding of human psychology and disease treatment. They conducted detailed studies of the human body and discovered how blood circulates, enhancing medical knowledge. Fifth, invention of the telescope and microscope of Galileo Galilei and Anton van Leeuwenhoek improved the telescope and developed the microscope, leading to discovery in astronomy and microbiology. Impact expanded observational capabilities, leading to significant advancements in various scientific fields. They improved tools that allowed scientists to see distant stars and tiny organisms, leading to a new discoveries. 6. Development of calculus of Isaac Newton and Gottfried Wilhelm Leibniz formulated the laws of motion and universal gravitation, unifying celestial and terrestrial mechanics. Impact provided a comprehensive framework for understanding physical forces critical for advancements in physics and engineering. They created a mathematical framework to describe change and motion, essential for advancements in science and engineering. 7. Chemistry's transformation of Robert Boyle. Transition from alchemy to modern chemistry, emphasizing experimentation. Impact laid the groundwork for the chemical sciences, influencing the study of gases and chemical reactions. He shifted the study of substances from medical alchemy to a focus on experimentation and scientific principles. Thank you, and Miss Aboy will continue the discussion.
Next is the shift of worldview, also known as Enlightenment thoughts. In Tagalog, mga kaalaman. So the philosopher and scientists in Europe, they gathered together to have this intellectual movement. So intellectual movement when their knowledge, observation, and understanding about metaphors. Metaphors are like God, reason, nature, and humanity. And all the Enlightenment thoughts or knowledge about it, they all combine it into one information. So the impact of shift of worldview. By their knowledge and scientific information, the other countries and culture is influenced. In the other country, they follow the strategy of enlightenment or the intellectual movement. In all the observation and reason, it led to a advancement of scientific thinking, technology, and medicine. Next is the impact of enlightenment thoughts. The idea of human reason and scientific investigation may advance society was known as enlightenment. These represent an arrangement towards norms and beliefs and a worldview that was more scientific and historical. The impact of Enlightenment thoughts is all the social and political issues have potential solutions. By the Enlightenment thoughts, they know the solutions to the problem easily. And the last is the technological innovation. So technological innovation is the advancement of different field of study. Like they try how to use the new tools and equipments, how to process information and enhance the research abilities. For example, the microscope and telescope. This technology may help the scientists to understand the world and the outside world. The impact of this technological innovation has a possible and lead to a new discoveries to understand clearly the world and the outside world. And also, the technological innovation is essential to us in this modern world. The next topic is the technological achievements of different Asian civilizations. The Asian civilizations, such as Egyptians, Greeks, Romans, Chinese, and Indians, they made significant technological achievements in areas like engineering, mathematics, astronomy, medicine, and architecture. So these advancements lead to the foundation for modern innovations and continue to influence our world today. First is the ancient Egypt. Pyramids. The pyramids is a massive stone structures like the Great Pyramid of Giza, showcasing the advanced engineering and construction techniques. The Great Pyramid of Giza is an amazing example of the advanced engineering and building methods used by ancient civilizations. It also demonstrates their mastery of massive alignment and exact stone laying processes. Next is the hieroglyphics, a complex writing system used for record keeping and religious texts. The hieroglyphics. It is a writing system in Egypt and they write it in the wall of the temple and in the stone structures. Because by this they write all the important events, cultural knowledge and religious belief to continue and for the next generation. And the last technological achievements of Egypt is the irrigation system. Irrigation systems. Sophisticated methods for channeling water from the Nile to support agriculture. The Egypt has been the home of life for thousands of years, thanks to its irrigation system. So, irrigation system is a waterway being built and the water distribution techniques. This irrigation system has significantly benefit the crops yields and food securities by effectively channeling the water from the Nile River for their agricultural. The next Asian civilization is Mesopotamia. The first example is the cuneiform writing. One of the earliest systems of writing developed by the Sumerians for record keeping and literature. This writing system is featured a combination of pictographs and abstract symbols. They write it into a clay tablets. Using a red stylus, they used it to mark on a clay tablet. By the cuneiform writing scripts, they written the important documentation of laws, economic transactions, religious beliefs, and historical events that written in tablet for the next generation. The next is the wheel. Innovation of the wheel is crucial for transportation and pottery. The wheel is initially used for pottery, transportation, and labor practices in ancient Mesopotamia. By this, it reduced effort in transporting goods and people and facilitating empire expansions, trade, and societal development. The last example is Mesopotamia mathematics. The mathematician additionally plays the fundamental elements for the use of mathematics by creating the exact formulas for science, timekeeping, calendars, and mathematical tables.
Good morning, everyone. I'm Joy Panes. So today I will discuss first the ancient China. Ancient China contributed countless inventions to the world. First, we have the paper and printing. The invention of paper and early woodblock printing revolutionized communication and record keeping. The development of paper is a testament to the advanced science and technology of ancient China. The history of improved paper making begins in 105 AD when Kailon, a Han Dynasty court official, made a sheet of paper from hemp waste, fishing nets, and other coarse fibers. Gunpowder. Development of gunpowder leading to advance in warfare and technology. The gunpowder, originally from the East, this substance is a mixture of sulfur, charcoal, and saltpeter or a potassium nitrate. Compass. Early magnetic compasses that aided navigation. Compass, a new chapter in the history of navigation, began when Chinese seamen began using the compass for celestial and earthly navigation in the late 11th and 12th centuries. Originally, the compass was utilized for geomancy or the art of aligning buildings and for religious purposes.
Ancient India is known for being the birthplace of Indian civilization. Iron smelting, advanced technique in iron smelting and metallurgy, exemplified by the Iron Pillar of Delhi. Iron smelting, constructed by Chandragupta II, the Iron Pillar of Delhi is a column that is 7.21 meters high and has a diameter of 41 centimeter. It is currently located in the Qutub complex at Mehrauli in Delhi, India. Zero and decimal system. Introduction of zero and a decimal system in mathematics, foundational for modern arithmetic. Zero and decimal system. The Indus Valley Civilization, which existed between 2500 and 1500 BCE, may be the source of India's first documented use of a decimal system and zero. An illustration of this is the modern zero, which was first used in ancient India, is a crucial part of the decimal system. Medicine, early practice in surgery and medicine, including the use of herbal remedies. One example of Indian herbal treatment is Ayurveda, which is the most ancient yet living practice. Ayurveda is a system of medicine based on the idea that disease is caused by an imbalance or stress in a person's consciousness. Ancient Greece, the cradle of democracy, produced some of Western civilization's finest literature, architecture, science, and philosophy, as well as breathtaking historical sites like the Acropolis and Parthenon. Archimedes' screw, a device for raising water used in irrigation and drainage. Archimedes' screw, named after its inventor, Greek mathematician Archimedes, is a mechanism used to raise water. Essentially, it is a giant screw with two open ends and a watertight covering throughout its length. Antikythera mechanism, an ancient Greek analog computer used to predict astronomical position and eclipses. It dates back to the 1st or 2nd century BCE. It was discovered in 1901 from a shipwreck on the Greek island of Antikythera. Olympic Games, advanced sports, infrastructure, and organization for the Olympic Games. Ancient Olympic Games took place in Olympia, Greece, every 4 years from 776 BCE to around 393 CE. The word Olympus, which referred to the Mount Olympus, the resident of the Greek gods, originated from this religion festival honoring Zeus. Ancient Roman or Ancient Rome civilization, from the founding of the Italian city of Rome in the 8th century BC to the collapse of the Western Roman Empire in the 5th century AD. Concrete. Development of Roman concrete used in durable construction projects like aqueducts and the Colosseum. The Romans developed a new recipe for concrete using pozzolana, a volcanic ash found in southern Italy that mixed with lime and water to create a sturdy, resistant form of concrete. Roads and aqueducts. Extensive network of roads and aqueducts for transportation and water supply. The Roman aqueduct was a waterway that transported fresh water to densely inhabited areas. Aqueducts were incredible engineering accomplishment for their time. Though earlier civilization in Egypt and India constructed aqueducts, the Roman improved on the design and created a vast and a complicated network spanning their kingdoms. Aqueducts can still be seen in portions of France, Spain, Greece, North Africa, and Turkey. Aqueducts required extensive planning. They were constructed from system of pipes, canals, and bridges. Architecture. Innovation in architectural design, including the arch, vault, and dome. Roman architecture was innovative, incorporating new materials like concrete and improving the arch, dome, and vault. They combined this into magnificent structure with eye-catching decorative elements, profoundly influencing future architectural trends. Mesoamerican civilization are in Mesoamerica. The Maya civilization made the greatest progress in science and technology. Calendar system. Highly accurate calendar system such as the Maya long count. Ancient Maya using their knowledge of astronomy and mathematics, the ancient Maya created one of the most precise calendar system in human history. The ancient Maya were fascinated by cycles of time. The most well-known Maya cyclical calendars are the Hahab, Shulkin, and calendar round. Chinampas, artificial agricultural island used for farming and lake region. Chinampas are artificial agricultural islands constructed using rocks, muds, and soil to promote farming. Mathematics and astronomy, advanced understanding of astronomy and complex mathematical system. The Mayan society invented the zero, allowing many individuals to configure huge numbers. However, political leaders used astronomical knowledge to support and legitimize their control. Ancient Iran, historically known as Persia, was the dominant nation of Western Asia for over 12 centuries. Royal Road, an extensive road system facilitating trade and communication across the empire. Royal Road, ancient road running from Susa, the ancient capital of Persia, across Anatolia to Sardis and Smyrna, on the Aegean Sea, a distance of more than 2,400 kilometers or 1,500 miles. Zoroastrianism, early development of religious and philosophical ideas influencing future culture. Zoroastrian immigrants known as Parsis fled Muslim persecution in Iran and moved to India. Zoroastrianism has an estimated 100,000 to 200,000 adherents worldwide and is currently practiced as minority religion in parts of Iran and India. Now we will proceed to the next topic, which will be discussed by Mr. Gaborno.
Long-term impacts of early scientific discoveries on modern science. Early scientific discoveries have had a profound impact on modern science, shaping the course of research and development in various fields. Long-term impacts of early scientific discoveries on modern science. First, foundation of modern physics. Newton's law of motion and universal gravitation established the principles that continue to underpin modern physics and engineering. Second, scientific method. The emphasis on empirical observation and experimentation by pioneers like Bacon Descartes shaped the scientific method, which remains the cornerstone of scientific inquiry. Third, advancements in medicine. Early studies in human anatomy and physiology, such as those by Vesalius and Harvey, revolutionized medical practices, leading to modern medical science. Fourth, technological innovation. Inventions like the telescope and microscope by figures like Galileo and Leeuwenhoek opened up new fields of study, laying the groundwork for advancements in astronomy, biology, and beyond. Fifth, mathematical foundations. The development of calculus by Newton and Leibniz provided essential tools for modern science, crucial for fields like physics, engineering, and economics. The long-term impacts of early scientific discoveries can be seen in several ways. Number one, building upon previous knowledge. Two, advancing fields. Three, transforming society. And fourth, encouraging future research.
Development of science and technology. The development of science and technology has been a continuous process driven by human curiosity, observation, and the desire to solve problems. Prehistoric era. Early humans developed tools, controlled fire, and created rudimentary technology for hunting and survival. The discovery of fire and the development of language were crucial milestones. In this period, people have already developed skills and technologies which served and supplied their needs of survival. Ancient civilizations like Egypt, Mesopotamia, China, and Greece made significant advancement in agriculture, architecture, mathematics, and medicine. Writing systems, the wheel, and early engineering feats like pyramid and aqueducts were key developments. Improvement in scientific knowledge strategically changed the operation of inhabitants of the ancient kingdoms. Their way of life was considerably improved through this advancement. Middle Ages. Technological progress continued with innovation in agriculture, example, the heavy plow, architecture, for example, Gothic cathedrals, and early scientific exploration. The preservation and translation of classical knowledge also laid the groundwork for future advancement. Many advanced inventions were made during this period such as compass, gunpowder, spinning wheel, and printing press. Renaissance and scientific revolution. A renewed interest in science and experimentation led to breakthroughs in astronomy, physics, biology, and chemistry. The scientific method was formalized, and inventions like the telescope and microscope expanded human understanding of the natural world. Curiosity made people question their beliefs. This era encouraged people to investigate and explore to understand mysteries and search further answers that caused the birth of new ideas. Modern era. The Industrial Revolution brought about rapid technological advancement, transforming industries and societies. Today, science and technology continue to evolve, driving innovation in fields like computing, medicine, and environmental science, and shaping the future of human civilization. The modern era saw the rise of technologies such as reproductive technology, the television, man-made satellites, and personal computers, and many more.
So remember, every discovery and invention, big or small, has shaped the world we live in today. Let's continue to learn, adapt, and grow together. That's all. Thank you.